Okay, so today we're going to talk about something wild. Scientists have basically found a hidden map inside of chaos. Yeah, you heard that right. We're going to see how they're using this idea of networks to predict these huge, sudden events in systems that look totally random. And trust me, it is an absolute game changer.
You know, out in nature, things can just flip with no warning at all. I'm talking massive ocean currents suddenly going the other way, or even, get this, the Earth's entire magnetic field reversing its poles. And what you're looking at right here, it's a computer simulation of a fluid, and it's doing the exact same thing. It's just swirling along, all calm and peaceful, and then, boom! Out of nowhere, it violently flips and starts going in the opposite direction.
For the longest time, trying to predict stuff like this felt, well, impossible. It's just random, right? But that's the big question that kicked off all this research. What if? What if all that chaos isn't just random noise? What if there's a hidden structure underneath it all? Like a map that could actually let us see what's coming next.
And that, right there, is the core idea. Instead of just throwing their hands up and saying it's a random mess, these researchers decided to treat this chaotic flow like it was some kind of unexplored country, a new territory that they could actually map out.
Okay, to really get a handle on this, let's use an analogy. Think of the fluid's behavior as being like the traffic in some huge chaotic city. At any given moment, the way the fluid is swirling, that's like a specific location on the map, a single point in the city. And the goal here? It's to create the ultimate traffic map. Not just the big highways where everything is stable and predictable, but every single back alley and hidden side street the system uses to get from one place to another.
So, how do you even start to map a city you've never seen before? Well, you start by collecting a ton of data, right? That's what the scientists did. They ran this super detailed computer simulation of a fluid in a box heated from below. They just let it run and run and run, creating thousands of snapshots of its chaotic behavior. It's kind of like they put a GPS tracker on every single car in our crazy city to see exactly where it went.
Okay, so having a mountain of data is great, but turning it into a map you can actually use? That's the real trick. And to do it, the researchers used this really clever step-by-step process to turn all that mess into something that can actually predict the future.
So let's walk through it. Step 1, we already talked about, run the simulation. Step 2 is where they simplify all that data. They used a pretty powerful math technique. Think of it like taking a huge, complex piece of music and pulling out just the main melodies. They're filtering out the noise to find the big, important patterns. Then, step 3 is where we get to see it. They figured out they could describe the entire state of this complex system with just 2 numbers. Just 2, and you can plot that on a simple graph. And finally, step 4, the big one, they connect all those dots to build a network. And that network, that's our traffic map.
And this is what that plot from step 3 looks like. Every single dot here is the state of the fluid at one instant. You can totally see there's a shape there, something is emerging from the chaos, but it's still just a big, messy cloud. It's not at all clear how the system is moving around inside of it. This is where step 4 comes in, and believe me, this is the magic moment. The researchers basically laid a grid over that whole cloud of points. Each little box in the grid becomes a location. That's a node on our map. Then they just watched how the system jumped from one box to another over time. And those jumps? Those become the routes, or the edges of the network. And just like that, the mess has structure. We've got locations, and we've got the roads connecting them.
So, the map is built. Now the real exploration can begin. The researchers started to poke around, looking for patterns, for hidden neighborhoods inside their chaotic city. Which leads to the big question, right? Is this map just a giant, tangled spaghetti monster of roads? Or are there actual neighborhoods? You know, downtown areas where the system likes to hang out, and maybe some expressways that connect them. Is there an order hiding in all this chaos?
And the answer is yes, a huge yes. Just look at this. They ran a special algorithm to find communities, and what they found was that the network isn't random at all. It naturally breaks itself down into 6 distinct neighborhoods, which you can see here in the different colors. It's amazing. This shows that the chaos has a hidden structure. The system will chill out in one neighborhood for a while and then take a very specific path to get to another one.
And these neighborhoods aren't just random blobs of color. Each one means something very specific. See the red and blue ones? Those are the stable states. That's when the fluid is just swirling along happily in one direction. Think of those as the main highways in our city. Then you've got these other ones, the precursor communities. Now these are interesting. These are the off-ramps. The system always visits one of these right before it's about to flip.
Finding these off-ramps is the whole key to predicting what's next. And finally, you have the transition communities. That's the messy crosstown journey itself, where everything breaks down and reverses.
All right, so we have a map, we have neighborhoods, we know what they all mean. The last, and let's be honest, the most important step is to actually use this map to predict where the system is going to go.
See, because the researchers tracked every single jump the system made, their network isn't just a pretty picture. It's a powerhouse of probabilities. If you're in any one spot on this map, the model knows the exact chance you'll take one road versus another. It's literally like a GPS for a chaotic system, always calculating the most likely route based on your current location.
So, the million-dollar question, does it actually work? Well, just take a look. That gray line? That's the real, live data from a brand new simulation, one this model has never, ever seen before. And the black line? That's the model's prediction. I mean, wow, it's almost perfect. The model knows when things are stable, and it nails the prediction, seeing the system go into that precursor off-ramp state right before every single flip.
How accurate are we talking? Over 90%. That's incredible. Just by seeing when the system hits one of those precursor off-ramps, the model can tell you a reversal is coming with more than 90% accuracy. So this isn't just some neat academic idea. It's a real, working forecasting tool. And the researchers who did this work, they think this is just the tip of the iceberg. They literally say that this kind of data-driven approach has the potential to help us understand, predict, and maybe even control all kinds of complex systems, way beyond just a swirling fluid in a box.
Which really leaves us with a mind-bending final thought. I mean, if we can find a hidden map in the chaos of a fluid, what else could we map? Could we use this to predict when a hurricane is going to rapidly intensify, or find the off-ramps that lead to a stock market crash? Could we even use this to map the pathways of our own thoughts in the brain? The possibilities, they're just staggering.